Hello everyone. In this video, I will show you very basic knowledge about logic circuit, which is the foundation for our lab assignment for the logic circuit. In our textbook, go to lab essential 7 exercises. This is where you can find our assignment. But this here, logic circuit A, talk about some foundation for logic circuit. If we click on that, you will see some background about the logic circuit. The logic circuit has some very basic circuit components. Binary switch, NOT gate, 2-input AND gate, 2-input OR gate, 3-input AND gate, and 3-input OR gate. I like to go further to introduce their very basic logic. We know that computer hardware is based on digital circuit, and digital circuits are based on logic circuit, or digital circuit is also called logic circuit. Logic circuits are formed by these essential components. This is binary switch. Binary switch is to input 0 or 1. When it connects to 0, the output of the binary switch will be 0. When it connects to 1, the output will be 1. NOT gate. NOT gate is to negate the input, which means if the input of the NOT gate is 0, the output will be 1. If the input is 1, output will be 0. The AND gate is only when all the inputs are 1, output will be 1. Otherwise, any one of the input is 0, the output will be 0. OR gate, is when any one of the input, any input is 1, the output will be 1. Only when all the input are 0, output will be 0. Similarly, 3-input AND gate, when all 3 inputs are 1, output is 1. When any input is 0, output will be 0. For OR gate, 3-input OR gate, when any input is 1, output will be 1. Otherwise, when all the inputs are 0, output will be 0. So these are about the meaning of these gates. I just mentioned 0 and 1. Actually, digital circuit or logic circuit has only 2 levels, high or low. This is from the view of circuits, hardware circuits. It may have different levels, high or low. And generally, we use 1 to represent high level, and use 0 to represent low level. Okay. Now, I like to show you the truth table for the logic circuit for the gates here. Why we call them gates? Because this is just like a real gate or a switch that when there is input, we can open the gate or close the gate, something like that. So that's why we call them gates. Actually, these gates are the very essential, very basic logic circuits. Now for binary switch, the truth table for binary switch is when input is 0, output is 0. Input is 1, output is 1. Okay. And the truth table for NOT gate is when input is 0, output is 1. Input is 1, output is 0, because NOT gate is to negate the input for the output. For two AND gate, for two input AND gate, that means there are two input. We call them A and B. And we can list all possible combinations of A and B. Two input, they can be A0, B0, A0, B1, A1, B0, A1, B1. Only four possible combinations of input. Now, what will be the output? When A and we know that the meaning of AND gate is only when all inputs are 1 or high level, output will be 1 high level. So that means only when A is 1, B is 1, output will be 1. All other combinations of the input of A and B will be 0. That is AND gate. For three input AND gate, because of the definition of an AND gate, only when all inputs are high level or 1, output will be 1. All other combinations will be 0. Okay, for three input, we may have 8 possible combinations of the A, B, C, 3 inputs. So we list from the lowest 0, 0, 0 to the highest 1, 1, 1. We can list it like this: A 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. Okay, and only when all inputs are 1, output will be 1. For OR gate is when any input is 1, output will be 1. Only when all inputs are 0, output will be 0. So we list 4 possible combinations of the two inputs, A and B. When A and B both are 0, output is 0. When A and B or both A and B are 1, output will be 1. So this is the definition of OR gate. For 3 input OR gate, also there are 8 possible combinations of input. The definition of OR gate is when any input is 1, output will be 1. Only when all inputs are 0, output is 0. So the truth table shows the facts of the 3 input OR gate. When A and B and C, all of them are 0, output is 0. When any one of them or 2 of them or all of them are 1, output will be 1. Okay, so this is the definition of these logic gates. Okay, the logic gates. So these are something you need to know because they are the definitions of the logic gates. Okay, based on this, now I will create another video to show you how to use our logic circuits and meter to work with the logic circuits. See you in the other video. Bye.